Okay, section 4.4 is about the properties of logs. These are just how you manipulate logs, some of the things that are true about logs and how they work. The properties of logs are really the properties of exponents because logs are exponents. Okay, product property of exponents says that if you multiply like bases, like right here, then you add the exponents. So 2 to the third times 2 squared is equal to 2 to the 3 plus 2 equals 2 to the fifth. That's because 2 to the third is 2 times 2 times 2, and 2 squared is 2 times 2. So that gives you 5 of them. That's 2 to the fifth. So this is how exponents act. It's not some rule that somebody made up. It's just how exponents work. And this is the same thing about logs. We're not going to go through the proofs of all these, but this is just how logs are. So let b, x, and y be positive numbers where b is not 1. Then the log base b of a product, x times y, is equal to the sum of the logs of the factors in that argument. So in your argument, you've got x times y. So log base b of x times y is equal to log base b of x plus log base b of y. Okay? Write the log as a sum and simplify if possible. Assume that x and y are positive real numbers. So log base 2 of 8 times x is just log base 2 of 8 plus log base 2 of x. When you multiply factors in the argument of the log, you can write 2 or however many factors there are, you can write that many logs and add them up. So log base 2 of 8, we've already talked about. 2 to the third power gives you 8, so that log is equal to 3, and then log base 2 of x. So this would be the simplest that you could write that. Okay, natural log of 5 times x times y. So natural log of 5 plus natural log of x plus natural log of y. Okay, quotient property of exponents says that if you divide like bases, you can subtract the exponents. So 2 to the fourth over 2 to the third is 2 to the 4 minus 3, which is just 2. And this is the way exponents act. If you have 2 times 2 times 2 times 2, 2 to the fourth, over 2 to the third, 2 times 2 times 2, 3 of those are going to cancel out, and you're just going to end up with 2. So this is how exponents act, and therefore this same kind of thing happens with logarithms. So log base b of x over y is equal to log base b of x minus log base b of y. So the log of a quotient equals the difference of the log of the numerator and the log of the denominator. All right, so if we have log base 3 of c over d, we can write that as log base 3 of c minus log base 3 of d. Part B, we've got log of x over 100. We can write that as log of x minus log of 100, and we know that the log, common log, of 100 is 2, so we could write this as log of x minus 2. Power property of exponents says that if you have a power raised to another power, you multiply the exponents. So b to the x raised to the y is b to the x times y. So 2 cubed squared is equal to 2 to the 3 times 2. And this is the way exponents act. If you have 2 cubed, that's 2, 2, 2, 2 times 2 times 2. And if you square that, you're going to have another 2 times 2 times 2, and that is equal to 2 to the 6th. And so that is how exponents act when you are dealing with like bases. And the same thing is true for a log. If you have the log base b of x to the p power, you can change that to p times log base b of x. So let's look at the power property for logs. You've got the natural log of the fifth root of x squared. First of all, we can change that root to a fractional exponent. So that would be the natural log of 2 of x to the 2/5. Now we can take that 2/5, that exponent, and just put it right in front of the log. So 2/5 times natural log of x. Down here you've got log of x squared, common log. You can just take that exponent and put it in front of the log, 2 log x. And for a table of all the properties of logs that we've learned so far, you can see page 445. All right, write logarithmic expression as the sum or difference of logarithms. We've got log base 2 of this quotient, so we're going to write it as a difference of logs. So log base 2 of z cubed minus log base 2 of xy to the fifth. Now, on this first log, we've got an exponent on our argument, so we can put that in front of the log. So we'll have 3 log base 2 of z. Now, this log, the second one, is a product of x and y to the fifth. So we're going to go ahead and write that as the sum of 2 logs, but we need to put it in parentheses because we have a minus sign here in front of the log, and that's going to need to be distributed. So we can rewrite that as log base 2 of x plus log base 2 of y to the fifth. Now, I'm going to distribute that minus sign and bring down that exponent in that last log. So 3 log base 2 of z minus log base 2 of x minus log base 2 of y to the fifth, but I'm going to bring that 5 down in front because of that last property that we talked about, where you can bring that exponent down in front and it will be multiplied by the log. So this is what your log would look like. All right, over here on the right, on part B, we have the cube root of this whole quotient here. So the first thing we're going to do is just rewrite it as, I'm going to write it as log of x plus y squared over 10, and the whole thing is raised to the 1/3 power. Now I'm going to take that 1/3 and put it in front of the log. So 1/3 log of x plus y squared over 10. Now I can write that log as a difference because it's a quotient. So 1/3 times the log of x plus y squared minus the log of 10. For that first log, I have the argument has been squared, so I can take that exponent and put it in front of the log and multiply it by the log. So I would have 1/3 times 2 log x plus y minus log of 10. And since that's a common log, we're asking what exponent do you put on 10 to get 10? And that exponent would be 1. All right, so now we could distribute that 1/3 and make it 2/3 log x plus y minus 1/3. And here is where sometimes it gets confusing, because sometimes if you see a sum in your log argument, you think, oh, I can add log x plus log y. But no, that is not true. What's true is log x times y is equal to log x plus log y. But if you've got a sum in your argument, you can't do anything with that. You have to just leave it alone. So I'll just say it one more time. Do not try to simplify log x plus y. The argument contains a sum, not a product. So this cannot be simplified. But this can be simplified. If you have a product in your argument, then you write it as a sum of logs. Okay, write this expression as a single log and simplify the result if possible. So now we are going to go backwards. We're going to take these logs that are sums or differences or whatever, and we're going to write them as just one log. All right, so you've got subtraction going on here, which means you're going to have things being divided in the argument of the log. So I'm going to rewrite this as log base 2 of 560 minus the quantity log base 2 of 7 plus log base 2 of 5. And you could do this a couple of different ways. So now I can write that sum of 2 logs as just log base 2 of 7 times 5. Because when you multiply in your argument, you have 2 factors. You can add the 2 logs. So I'm just going backwards. I'm saying I added 2 logs together, and that is the same thing as just taking the log of the product of those 2 arguments. All right, so now I have subtraction here between two logs, which means that I can divide the arguments. So log base 2 of 560 over 35. And log base 2 of 560 over 35, 16. So log base 2 of 16, you're asking what power would I put on 2 to get 16? And that is 4. 2 to the 4th is 16. All right, write the expression as a single log and simplify the result if possible. All right, again, we have this subtraction going on, so I'm going to rewrite it as 3 log A minus the quantity 1/2 log B plus 1/2 log C. Okay, so what I'm going to do, there are probably many different orders you could do this in. So I'm going to go ahead and put this 3 right here into the exponent of the argument. I am allowed to do that. So log of A cubed. And then I'm going to do that over here also. I'm going to put 1/2 into the exponent of that argument, and I'm going to put 1/2 into the exponent of that argument, but I'm going to write it as a square root because anything to the 1/2 power, that just means square root. So I'm going to write log square root of B plus log square root of C. Now I am going to write log square root of B plus log square root of C as the log of the product square root of B times square root of C, because I know that if I add two logs, I can just take the log of the product of the arguments. So log of A cubed minus the log of square root of B times square root of C, which is just a square root of B times C. Now I am subtracting two logs, which means that I can write that as the log of the quotient of those arguments. So log of A cubed over the square root of BC. Okay, here's another one. We've got 1/2 natural log of x plus natural log of x squared minus 1 minus natural log of x plus 1. All right, so first of all, I'm going to take that 1/2 and put it into the exponent on that first one, and therefore it will just be the natural log of the square root of x. So natural log square root of x. Then I have natural log of x squared minus 1 minus natural log of x plus 1. And since there's a plus sign there, it doesn't matter if I put parentheses around this. That's the difference of two logs, which means I can take the log of the quotient of those two arguments. So x squared minus 1 over x plus 1. And I know that x squared minus 1 is a difference of squares. And so I can factor that. So I'd have natural log of x square root of x still there, plus natural log of x plus 1, x minus 1 over x plus 1. And those will cancel. And so natural log of the square root of x plus natural log of x minus 1. And now I can rewrite this as the natural log of the product of those two arguments. So natural log of square root of x times x minus 1.